Hello everyone and welcome to a new Lifehack. My name is Patrick and today I would like to show you a feature in Fidelity that will simplify your workflow to create an unstructured mesh for your turbo machine. So of course for turbo machines we usually have Autogrid. However, there are certain types of machine configurations that will make creating an unstructured grid a little bit difficult. And I will show you a way today how you can set up your turbo machine geometry in Fidelity and then automatically create a watertight domain that you can use to create an unstructured grid in Hexpress. So again, before I get started, everything that I will be showing you today, you will also find in the user guide. So I recommend that you take the Cadence Doc Assistant. And then here you can simply enter, let's see, geometry 4. And then there should be a suggestion here, geometry for Fidelity Hexpress. And then it should be the first one right up here. And all the limitations and the general procedure about what I will be showing you today, you will find here. So maybe to explain a little bit better what I'm going to do, I have prepared a few slides for you. So let's get started. Our demonstrator will be an axial inducer that we will mesh with Hexpress, followed by a radial pump that we will mesh with Autogrid. And the idea will be that we will combine both these meshes later in the simulation. So maybe let's go a little bit onto the difficulties. The challenge here with this axial inducer is that we have a very strong sweep in the leading edge. We have a sheared leading edge, which will make it difficult to create an unstructured grid with Fidelity Autogrid. It is possible, and we will see that later. However, the idea of this whole approach is that for certain turbomachinery types, for certain turbomachinery geometries, an unstructured grid might make more sense. And the nice thing about Fidelity is that you can simply combine unstructured and structured domains in Fidelity and put them all in one simulation. So the challenge here usually is to define the domain or the geometry of your turbo machine, because you always have the challenge to set up your periodic boundaries, because we usually want a single passage model. So I'm going to show what we will actually will be doing. So if we take a single passage model of our inducer, there is a way to set this up as a turbomachinery configuration and then let Fidelity automatically create the watertight domain. So as you can see here, after we applied this option, Fidelity will have created the inlet, the periodic boundaries, the blade geometry, and of course hub and shroud. And you can take this domain and take it to Hexpress and run either a surface to volume mesh or a volume to surface mesh, whatever you prefer. And then you can run the mesh in Hexpress and you should up with a nice grid. And I show you some examples or some images of the demonstrator that I used for this Lifehack. Okay, so I hope that wasn't too quick. I will go to the interface right now and I will guide you step by step through the process. So here I am in Fidelity. Essentially what I did was simply to open a turbo template. Everything I will be showing today will be in the turbo template. And I will just get started by importing the geometry. Let me just see where I have it. Let's see, Lifehacks. And as I indicated in my first slides, we will have a 2-row configuration with an axial inducer and a radial pump. And we will be creating the structured grid for both of them. However, the main focus will lie on the axial inducer to create the watertight domain and then mesh it with Fidelity Hexpress. So let's get started. It's actually not that much to do. As you can see, we get a preview of our Turbomachinery configuration, and I created this by importing a GeoMturbo file. However, you do not need a GeoMturbo for that. So in general, what you can also do is, let me just delete this real quick. You can also just create a Turbomachinery configuration and import a CAD file and set up everything from scratch. That's also possible. However, to simplify, what I would like to show today is I will work with the GeoMturbo. So the first step is you have to make sure that your Turbomachinery configuration is valid. All the surfaces are defined. You have the leading edge, trailing edge, and everything. And as soon as that is the case, you can simply click on the row that you would like to use to create the unstructured mesh. You right-click, and then there's this option here, Create Domain Geometry. As you can see, it is still a beta feature, so it has its limitations. So, but I will just press this right here, and I would like to draw your attention here to this geometry, and you will see what's going to happen. So please consider that this is an operation that is currently still running on the main thread. So your user interface will freeze for a second as long as this operation is going on. But as you can see now, it has created this domain right here. So we have the periodic boundaries, we have our inlet, we have our outlet. And this domain right here, we can now use to build our case with Fidelity Hexpress. So I'm actually done here. I can close this. I will go to Mesh. And what you see right here is the Autogrid configuration, and we can still use this to set this up. So I will do this real quickly. Let's see. I have an inducer here, and I have a radial pump here. Let me see, centrifugal pump. I will just apply the wizard real quick. So let me just show it. So here I have set up the wizard. I have set up my blade-to-blade mesh. And now I could simply create my mesh right here. Let me just save this, run this. And while it's creating the structured grid, I will create a new mesh setup for my axial inducer. So I will go to New Mesh. I will create a new mesh setup for Hexpress. And now I will simply add the domain that I used before to create my domain geometry. So add domain, close. And if I now switch to the 3D view, let's maybe close this. Now I have a domain right here for my mesh setup in Hexpress. And now there are different ways to proceed. Maybe let's take a first quick look at the geometry. So let me just maybe hide the periodics. I will hide the inlet, which all has been done automatically. I will just hide the inlet and the shroud. So in here I have my geometry, which I can now mesh. And you can do that with a volume to surface mesh or a surface to volume. In my case, I will choose a surface to volume mesh. I'm going through this pretty quickly because this is actually not really the main content of this life hack. So we talked about surface to volume a couple of life hacks ago. If you have questions, just let us know. What I'm going to do is I will apply some mesh settings here to obtain a nice grid later. Okay, I probably forgot something. Let me just save this and create the mesh, and we will be looking at it as soon as it's finished. So as long as the unstructured grid is being generated, let's take a look at the structured grid. So on first sight, if we take a look at it, here we have our axial inducer in the blade-to-blade plane, as well as for the radial pump. If you take a look at it, you see Autogrid is actually doing quite a nice job. The problem, however, appears if we take a look at 100% span and take a closer look on the sheared leading edge. Because what you're going to end up here, and that has nothing to do with the capabilities of Autogrid, but due to the sheared leading edge, what we have here are cells with a very low orthogonality. So everywhere else in the main flow channel, we are good. We are very good here in the centrifugal pump. However, at certain locations where the geometry simply becomes difficult, the structured approach might need some help here from the unstructured grid. So this is the main reason why I showed you this today. So let's just wait for a second until the unstructured meshing is done. So as soon as that has been completed, you should end up with something like this. So here we see the overall domain. What we are looking at here are the periodic boundaries. You can see the viscous layers approaching from hub and shroud. And let's just maybe deactivate those as well as the shroud and take a look at the blade itself. So here you can see we have a very nice surface mesh, including also an anisotropic edge refinement. I will get to that in a second. We can take a look at a cutting plane at 50% span. So I would say all in all, this is something we can work with. Before I wrap this up, I would like to address some settings that I applied because I went through that pretty quickly. Essentially, the idea is to keep the user input as minimum as possible. So essentially, all I did was I applied a global cell size together with insert buffer and viscous layers. In the local settings here on the mesh setup, I applied a curvature refinement with a minimum cell size, which is probably not even necessary. So the minimum cell size, just the curvature refinement. And then I also added viscous layers to the impeller main blade, hub and shroud. So you can add your settings right here. And I deactivated the buffer for inlet, outlet, and the periodic boundaries, right? Because it's simply not necessary to have a buffer and or a viscous layer at this location. And the last setting that I applied is, which is a result of what you see right here, I applied anisotropic edge refinement. So you can tell Fidelity that you would like to capture this curve, for instance, right here, or this curve right here with anisotropic edge refinement. All you have to do is you have to select this leading edge surface, pressure and suction side on one set. Let me just go to the settings. So I'm talking about here this proximity refinement, where you can select anisotropic edge refinement with a certain cell size. You select the surfaces that you want, and then you get this cell distribution right here. If you're not familiar with anisotropic edge refinement, be sure to look at our Lifehack 30, I think it was, where we talked about this when we created the grid for also a radial compressor, but for the solid. All right, so I think this was almost everything that I would like, that I did want to show today. The last important information that you need is if you want to use the unstructured and the structured domain in the simulation. So let's set up a simulation real quickly. I go to new simulation, and it's important that as soon as you have an unstructured mesh domain in your model, you will need to use the open solver, not the turbo solver. So I switch to open solver and add both domains, so the axial inducer and the radial pump. Let me close this and enhance this view right here. And by default, as you will see, you will end up with the structured grid for both domains, which is okay for the radial pump. However, we would like to use the unstructured grid that we created with Hexpress. So what you have to do here is, here in channel, be sure to have the channel defined by the geom turbo. So at the beginning, we imported a geom turbo. That will be our channel geometry. And for the first domain, if we open this up and go to choices, here you have two choices for the axial inducer. The structured grid created by Autogrid or the unstructured grid created by Fidelity Hexpress. So be sure to switch here, and then it will apply a few or change a few settings. And then, as you can see, now we have the unstructured domain for the inducer and the structured domain for the radial pump. And now you can simply continue and set up your simulation, apply your boundary conditions, and run the case. Also note that later you will still be able to have all the turbo capabilities for the post-processing. So you will be able to calculate the meridional average, the blade-to-blade view, everything you're used to when you use an unstructured, when you use a structured grid. You will also be having these options for the unstructured grid that we created. So this is not a limitation. So I hope this helped. Be sure to leave us feedback. Please also keep in mind that this is still a beta feature, so it might not always work on all geometries. As I mentioned at the beginning, be sure to take a look at the documentation, which will repeat slowly everything that I just told you. Have fun with it, and see you the next time.